Hello, everyone. Welcome to Sink or Swim, building platforms you can see. Woo! We have apparently the die-hard KubeCon, Cloud Native Con crowd here, 5:45. We're really excited. We actually were curious, though, about what our distribution here was. So if you could do a little audience participation. Survey, how many platform engineers in the room? Okay, good representation. How about end users of platforms? All right, we have content for both audiences. We're actually hoping to make the platform end user experience better, and certainly platform engineering is hard enough when it's hard to see what's happening in the platform. So. I'll tell you a little bit about us. I'm Mike Cutsail. I'm a software engineer at Apple. I've worked on infrastructure and connectivity solutions for about 10 years at Apple. And Heather.
Hi everyone, nice to meet you. I'm on the same team as Mike, working on infrastructure, but prior to working on infrastructure, I was an application engineer, so I care a lot about building platforms that you can see. And also, by the way, thank you everyone for coming at 5:45 p.m. to see our talk. So what are we hoping that you'll take away from this talk today? First, we want to give you a shared understanding of the observability challenges that platform teams face. We'll describe some of the unique problems that emerge when you're building platforms for developers. We'll be talking about making those platforms visible to two core audiences: platform engineers and platform end users. Second, we're going to show you the actual observability signals that you can produce from a real platform stack using a mini version of a production stack. And third, we'll share best practices for composing these instrumentation patterns together. The goal isn't visibility for visibility's sake. It's about rapidly assessing platform health when something goes wrong, and only surfacing the data that matters for the right audience. By the end of this talk, you should be able to go back to your platform and start applying some of these techniques. So let's start by talking about the agenda. This is what we'll be covering today. First, we'll walk through our tech stack we used to build the demo we'll be showing today. Next, we'll discuss the issues we might see arise from using this kind of platform. And then we'll go and walk through some demos to illustrate how we might address these issues from both the platform and user perspective and for the platform operator. Finally, we'll discuss how we built this observability into our platform and finish off with some questions. Sound good? Okay, great. Now, we'll give a brief overview of the components we use to build out the demo platform. Mike, over to you.
Thanks, Heather. Crossplane extends Kubernetes to manage any infrastructure through APIs. Cloud resources, DNS, storage, even Grafana dashboards. Everything becomes a Kubernetes resource. Managed resources are one-to-one mappings of actual infrastructure as Kubernetes objects. For instance, a cloud provider role or a security group. And composition is the key feature. When Team A requests a cluster, they're not creating 15 separate resource claims individually. The composition template is automatically generating all of the underlying resources: the API server, the node pools, security groups, cloud provider roles, everything to get the job done. Composition functions include the full power of custom code when you're rendering the template from the claim. Composite resources like X cluster represent the actual instance of your composed infrastructure, the real state of what's been created. And claims are what teams use: a simple namespace scoped request. Team A requests a cluster claim, creates a cluster claim. Crossplane creates the X cluster and then all the underlying resources. Claims provide the ownership boundary. ArgoCD is our GitOps engine. It automates pulling from Git and syncing to Kubernetes. As developers commit infrastructure claims, ArgoCD continuously pulls changes and syncs those to match what's in the repository. If someone manually changes a claim, Argo detects the drift and self-heals to the desired state. GitOps is at the heart of our declarative infrastructure. Now Heather will tell us about the rest of the stack.
Thanks, Mike. OpenTelemetry, or OTel, is the CNCF standard for collecting metrics, traces, and logs. What makes it powerful is its flexibility. We use it to instrument our custom Crossplane functions, collect traces, convert those traces into metrics, and then create unified data pipelines. If you're not using OTel yet, this talk will show you how powerful it can be. So you can see all the elements that we've discussed reflected in our demo stack here. We'll be showing a kind cluster running locally and not a production-ready deployment. Think of it as a mini version to demo what is possible in terms of observability in the real world at a larger scale, though. We have Crossplane running with a custom composition function and a full observability stack. We'll see this in action in a few moments. For those of you who aren't familiar with Crossplane or some of these other components, no worries. We will dive into some of the core concepts behind each layer in this architecture. With this, let's take a look at some examples of use cases with this sort of platform. Okay, so the platform Kubernetes API serves as the central interface, exposing higher-level abstractions through custom resources. There's 3 example claims on the screen here. We can see the cluster claim, which creates Kubernetes clusters and associated security policies, the database claim, which creates secure and compliant databases, and a custom security policy claim, which manages granular security policies. And on the right, we can see that Crossplane has provisioned resources in the respective team environments. Teams make simple declarative requests through the platform Kubernetes API without needing to understand the underlying cloud infrastructure details. Crossplane handles the translation from these high-level claims into actual cloud resources with proper isolation through separate accounts. Each team gets what they asked for, configured to platform standards, which is great, right? Now Mike will discuss some observability challenges, though, when using this type of platform.
Indeed. The end users of a platform need to know what's going on with their claims. Picture this. A platform user commits a claim. ArgoCD detects the new commit, and now the claims app is out of sync. Auto-sync is enabled. We triggered a commit sync to the platform control plane. It's a Crossplane claim which will turn into a set of managed resources. The Crossplane providers go out and create all the resources they need to fulfill the claim. Or did they? How does a user know whether they got what they asked for? Let's walk through some real scenarios we've dealt with, platform engineers have dealt with, using the demo project. First, we'll review some platform use cases and we'll highlight the observability signals. Then we're going to demo the solutions that we've come up with to provide a connected view in the hopes of bringing these scattered signals together. Back to our developer who commits a claim. Developer makes a PR for a Kubernetes cluster. What tells them that the cluster is ready to use? Or if there's an issue with their claim, or with the platform. Let's see this in action. We're going to jump into a demo where we'll show ArgoCD and Grafana that work together to surface this information with little effort. Now, we've got a claim pull request that's just been merged. I'll just take a look at the contents. This contains 3 claims. Demo cluster claim is the resource type. ArgoCD has already picked it up and synced it to the platform control plane. We can go and verify the demo cluster claims are part of our ArgoCD application, are showing up, and the health of those resources is being tracked by ArgoCD. They show up as progressing. The X demo clusters are the composite resources created by Crossplane. Remember, this is the instance of the composition that is instantiating the claim and becomes the parent of the managed resources. But we notice that one of our resources shows up as in a degraded state. This is something Argo can tell us. It is able to track the child of the composite, and then the composition helps generate the composite when the claim is put in the cluster, and Argo has copied these tracking annotations onto the demo cluster claim, and that parent lineage is propagated all the way down. So we can actually see that, and we've clicked a link from ArgoCD that's actually taken us directly to a Grafana dashboard that is filtered to look at the application state, the state of the objects in Kubernetes associated with this claim. So we can actually see in this filtered view that some of the resources are unhealthy. Of course, this is very similar to what ArgoCD has shown us, but we actually can see the entire resource state of just the one claim and all of the managed resources associated with this claim in a single pane. With a simple sort or filter operation, you can quickly identify which resources are healthy and which aren't. If we wanted to go and zoom out a little bit from the claim and look at all of Team A's resources, we could just remove that filter. Remember, we got here by clicking a link from ArgoCD, but we also have other views we can leverage from this dashboard. So we've removed a filter for the claim itself. Now we're looking at all of Team A's claims. So picture yourself as a platform end user on Team A. You want one place that you can go and see the health of all of your managed resources. This dashboard is an ideal place to aggregate all of that information. And as the state of your resources may change over time, let's say you have created a new claim, you want to track the health of that claim as it becomes ready and available, or let's say you've changed an existing claim and the change doesn't propagate the way you think it should, you could go to this sort of view and quickly see not just the composite health, but also all the underlying managed resources, so you can quickly identify what a root cause is, what you need to change to get all the resources into a healthy state. So we see out of the 3 that we've provisioned, 2 of the 3 became healthy, which was expected. And now from the platform team's perspective, you've removed another filter. We're no longer looking at only Team A's resources. We're actually looking at all of the resources that are managed by the platform across all the teams. So this could give you, as a single pane, the aggregate health of the platform. And this view contrasts with the ArgoCD view, which tends to be application scoped. So you actually are able to connect these 2 views together through those external links from ArgoCD. Heather is going to show us the next scenario.
Okay, cool. So we have not 1, but 2 demos for you. This is the second scenario. You are on the platform team. You push a change to your composition function. But this function affects every cluster claim across multiple teams. Questions immediately arise. How many resources are affected by this change? Are there any unintended side effects? If something breaks, can you trace exactly what the function did differently? You can't be certain. You won't know there's a problem until teams start filing tickets. And when they do, you have no audit trail of what changed or why. Okay, so let me set the stage for the second demo. I'm the platform engineer maintaining this platform, and I need to push out a new function release. Here's the situation. I've added conditional logic to handle environment-specific configurations. Staging clusters should skip cluster auth resources since we handle authentication differently in staging environments. This doesn't really make that much sense, to be honest, but let's just go with this, right, for the example. I've tested it locally, and it looks great. But spoiler alert, my code has a bug. I've accidentally introduced logic that will remove cluster auth from existing staging clusters. Oh no, I don't know that yet though. Let me show you how our observability catches this. We'll use ArgoCD, Grafana, and Jaeger to trace our platform change through the entire system, measure its impact, and create that audit trail. Okay, so this is our ArgoCD, and we will see that I'm on the latest tag right now. So I have two dashboards here, an overview dashboard and a trace details dashboard. And this one's a more detailed view of the first dashboard, and I'm just showing all the tools that we'll be using this demo here. So let me pull up the code, and I've created a tag named broken, just for the purposes of saving time here. And I'm gonna go and I'm gonna commit this and push this to Git. And as we push this, we should see these changes in Argo. Now, I'm gonna, even though I have auto sync on, I'm just gonna manually sync it to make everything fast. And then I'm gonna go in and double check. Okay, now I'm at the broken tag. So everything's reflected here. Great, I just broke my cluster, or staging clusters. And so let's pull up the overview dashboard. Okay, so there's some really helpful panels here. I can see total reconciliations and failed reconciliations. I can also see exemplars, so that is great. We have exemplars from our Jaeger traces. And filtering by a trace ID, this is a working trace, nothing really alarming here. We can filter and see claim namespace, and cluster name. And all of this is configured in my function, composition function code. So some other interesting things are I can filter by git commit, or look at the git commit that corresponded to this trace, as well as add span events. So this is quite wordy or verbose, but it's helpful, right? I can see everything in my function. I can even see each portion of the function as well, and what resources or managed resources were updated here. And so how did I do that? Well, you might be saying, well, I have like 100 resources in my composition. How am I gonna track them all through this function? Actually, so I'm opening up now an example of how to do this. So we just simply concatenated the name of the resource to the build. So you can do this in like a single function and not have to go and manually add this all to your individual functions. Okay, great. So let's go back to the dashboard and take a look at the overview. And everything honestly looks pretty good. I have no failed reconciliations. But if I pull up the detailed dashboard, I actually see something a bit more nefarious now. Okay, I have 3 reconciliations with changes. And that's not to be expected. Something's broken here. So let's filter by has changes true, and I can use this exemplar. And I'm gonna query this with Jaeger, and I'm gonna run this query, and I will see what happened. Oh, okay, it looks like I removed cluster auth for my staging clusters. Okay, and I can see that through the claim name, the claim namespace, and the cluster name. I can also see other parts of the diff, which is helpful. Okay, so yeah, this isn't great, right? I can also see the time of the exemplar, and it's great because I have all these traces. This isn't a sampling, actually. I can go into Jaeger and look at every point in time and filter by these tags, which is a great feature. And it comes really quickly out of the box. So, okay. The other thing I wanted to check is, did I break my dev clusters? And I can also validate that here. I don't have to really go and run a bunch of kubectl commands. And I can see, okay, all the reconciliations have not happened, changed for the dev cluster. So just the staging cluster. All right. So what did this observability give me as a platform engineer? First of all, I get immediate detection. Within 30 seconds of the function deploying, I saw unexpected changes in the dashboard. The second thing was blast radius identification. I know that only staging is affected, not dev. I can filter by cluster to confirm scope. I also have root cause analysis. I can trace which code path caused the deletion and see the exact resources affected. And finally, I have an audit trail. I can trace which code path caused the deletion and see the exact resources affected. So without this observability, I might be getting Slack messages, hey, I can't access my staging cluster anymore. I might have a theory as to why, but I wouldn't be able to point my stakeholders to a clear visualization of what actually occurred. No timeline, no proof of blast radius, no audit trail of what changed. Now I can roll back this function release, fix the bug, and redeploy with confidence. Now that you've seen what we can do with these tools, let's talk about how you can put them to use. We'll walk through some of the technical details. This is where you'll get some examples of things you can take home and implement. Now Mike will tell you about how we collected this data.
We used two distinct paths to power these dashboards. For the resource-based metrics, Crossplane Kubernetes resources, we used cube state metrics to extract their state. For custom code in our composition function, as you saw in Heather's demo, we used OpenTelemetry to actively instrument the Go code and emit traces. These are independent pipelines that end up converging in Grafana, linking metrics to the traces via exemplars, giving us a unified view. Cube State Metrics is a well-known tool that generates Prometheus metrics from Kubernetes objects. With some lightweight configuration, it allows you to capture the state of custom resources in your cluster as time series data. We point it at Crossplane CRDs and tell it, give me the synced and ready conditions as metric values. We collect other labels as well, metadata. Cube State Metrics converts these into Prometheus metrics with consistent state. Consistent labels also. And so now we can alert on things like demo cluster claim hasn't been ready for 30 minutes, or we could build these dashboards that show the set of resources, healthy or unhealthy, apply the filtering that you need to, and as you recall, that's what we observed in our platform end user demo. And now Heather will tell us more about the tracing with OpenTelemetry.
So the other side of the coin to expose observability for platform engineers is OpenTelemetry. Our demo composition function emits traces in OTLP format. Then the OTel collector receives these traces and does two powerful things. First, it enriches them with metadata from your environment. Second, it uses span metrics connector to automatically generate metrics from these traces. So we instrument once in code, and we get traces for both debugging and metrics for dashboards. Features like this are what make OTel so powerful. Another lesson that we learned from the demos is that you can monitor your claims and composite resources, which gives you a bird's eye view of all your infrastructure. Even though Git only contains the claims, ArgoCD can be configured to add a tracking annotation, which helps trace the child resources created by the composite resource. This can help identify degraded resources at a glance, starting with applications which have a degraded status. Filtering based on application labels, projects, and clusters helps users and platform engineers rapidly assess underlying issues. One other notable thing to mention, you can use an external link annotation in ArgoCD to match up your resources to their associated Grafana dashboards. All right, Mike, let's wrap it up. What did we cover today?
Well, first, if teams can't see the platform, they won't trust it. Observability isn't optional. It's a core platform feature. Here we've shown common Kubernetes-centric tools like Cube State Metrics and ArgoCD to help everyone track the state of the platform that they care about. Second, use GitOps for everything, including observability. Version control your dashboards and alerts. Treat observability as code. Third, consistent labeling enables correlation. Use the same dimensions, the claim namespace, cluster metadata across your traces, metrics, and dashboards. And this is what lets you connect the dots. And with that, we thank you and are open for questions. Sorry, the question is, We're using
Crossplane a lot as a foundational.
in the demo we used Crossplane.
And then what kind of issues did you run into?
Issues, yeah. Well, the issues, observability is the core issue that we're here to help solve for folks who have been using Crossplane. So showing ways to make it observable, make the state of the system observable. Obviously, it's subject to change over time, having a way to capture it as time series data, and then having ways to extract explicit events of interest, something like your composition function suddenly changes with the template essentially when you're not expecting that to change. Those two examples that we demonstrated, those are common challenges.
I think there was one other thing that we noticed was just adding like too many fields to the observability, which adds higher cardinality, and you don't really want that. So it's knowing what to pick and what to leave out.
Yeah, we could just repeat it back. Go ahead.
In your first scenario, the self-service failure, can you drill down further into what the root cause was? You know, for example, if you're using Crossplane and you want to have an S3 bucket or something. I saw an error happen, but is there
Yes.
information to bring that back
Okay,
to the commit and reason about what caused it?
Okay, the question is, how do you identify root cause through the metrics? So, or with the demo, right? If we were to actually get to a root cause in that scenario, what would that involve? That would be more event. Like you could look at Kubernetes events to get some more meaningful status around the individual managed resource reconciliation failure. A lot of times those error messages are not, they do not actually tell you the underlying issue. Like for instance, you could get something that is not directly relatable, but let's say it's a permissions issue or something that doesn't necessarily show up. It's not a direct, it's not contained in the event. So,
Surfaces that there was an error, now it's up to you to
yes, to dig into that would involve, you've got to now have access to other signals. You could do some sort of event, you could certainly log events and do log-based analysis. For the purposes of this talk, logs, our experience, log analysis is it's very it's still evolving, I think, for controller-based ecosystems. And with Crossplane reconciling the different controllers that are reconciling these, doing the kind of getting the same view that you would get in a trace, we would surface that sort of error message in a trace more ideally. Oh, another question. Okay, the question was, how did we implement the exemplars for the traces?
What was your philosophy behind
What was the philosophy behind?
where it was appropriate at?
Oh, where it was appropriate. The exemplars are, I think the big win, as Heather pointed out, was the exemplars are automatically created on our behalf by the span metrics connector in OpenTelemetry, in the OTel collector, right? Did you want to talk more about?
Yeah, so when you use the span metrics connector, you can actually get your traces to, with just a few configuration changes in YAML, to convert to Prometheus metrics. And from there, all of your traces, all of your metrics are then like tied back to the trace ID. So we didn't really have to do extra work to get those two things to connect after adding that.
The main effort is around selecting the dimensions that you want to extract as metrics. This goes back to our consistent labeling, and you want everything to be correlatable from the ways that you tend to aggregate. And Crossplane, those dimensions are fairly clear and straightforward. Resource types, I mean, these are Kubernetes objects, so you want to look at all of a given API group version kind, and then certainly you want to look at things that are kind of have the same parent claim and composite.
Thank you all for your questions.
Thank you.